Hello, and welcome to Data Engineering with Subhadeep. In this video, we will explore the power of event-driven architectures by building a serverless data pipeline using Google Cloud PubSub and Cloud Functions. First, let's understand the basics. An event-driven architecture is a model where services react to events as they happen. Its key characteristics are that services are decoupled, scalable, and highly resilient. For our pipeline on Google Cloud, we will use two main services. Cloud PubSub will act as our messaging backbone to ingest events. Cloud Functions will provide the serverless compute power to process these events as they arrive. Here's a high-level look at the architecture we are building. A data source sends events to a PubSub topic. A Cloud Function is automatically triggered by each new message on the topic. The function then processes the message and loads it into our data warehouse BigQuery. Let's quickly go over the core concepts of PubSub. A topic is where messages are sent. A subscription is a stream of those messages for a specific consumer. A publisher sends messages, and a subscriber receives them. In our case, the Cloud Function will be our subscriber. Now let's talk about our data processing pattern. We want to avoid writing single records to our data warehouse constantly, as it can be inefficient. Our Cloud Function will process each event individually, but will use the BigQuery streaming API. This API is smart. It buffers incoming data and writes it to the table in optimized batches behind the scenes, giving us the efficiency of microbatching without complex code. Let's get practical. The first step is to create our PubSub topic. We can do this easily from the command line using gcloud. We'll run gcloud PubSub topics, create, followed by a name for our topic. Let's call it IoT events. Next, here is the Python code for our Cloud Function. It imports the necessary libraries, decodes the incoming message from PubSub, which is base 64 encoded, parses it as JSON, and then uses the BigQuery client to insert the data as a new row into our target table. Notice how we are simply passing a list containing our single JSON object to the insert rows JSON method. With our code ready and a file named main.py, we can now deploy it. This gcloud command deploys the function, specifies the Python runtime, and most importantly, sets the trigger. We tell it to watch our IoT events topic and execute whenever a message is published. Now for the exciting part, testing our pipeline. We can use gcloud again to publish a sample message to our topic. This command sends a simple JSON payload representing a sensor reading. This will trigger our function. If everything is set up correctly, after we publish that message, our Cloud Function will fire immediately. It will process the data, and in a matter of seconds you can query your BigQuery table and see the new row of data, a complete end-to-end serverless pipeline in action. So let's recap the benefits of this architecture. It is extremely scalable, handling massive swings in data volume automatically. It is highly cost-effective because you only pay for the exact resources you consume. It's a low-maintenance serverless solution, and it provides true decoupling between your services. And that concludes our walkthrough of building a serverless event-driven pipeline. You now have a powerful pattern for real-time data ingestion. Thank you for watching. If you enjoyed this video, please like, share, and subscribe for more data engineering tutorials.